Hello people. So we are continuing with this madness of geometric neuron, and I think slowly I'm getting this vibe like how it might work, what might be the sort of thing about it. Um, of course, so if I think I know something, it can't be true, but okay. So what we were talking about earlier was the action initial segment by sorry guys, Christopher Christopher Leterrier, who was looking at the action initial segment. So we have neuron with these dendrites that we replaced with sort of like we're thinking kind of like Taken's delay, mathematical algorithm Taken's delay thing, and you can do all sorts of cool stuff with that. And so of course neuron is kind of like this octopus. It's growing these dendrites towards other neurons. Then there is an action that sends a signal forward. And basically what happened was, again, I'm sorry guys, but I have to show this to you. One new thing here coming up, but what the heck was I doing? I was saving, no, we are loading. But so the idea started like, and we can actually see when it started about, it started, this is actually not true, it wasn't, it was the last September, October, or something like that. But so I was just completely, utterly bored out of my mind and thinking about neurons. And so we had the homeostatic coupler. So, long story short, the neuron it tries to be in homeostasis with its environment. I guess electrically keeps certain sort of threshold and then it has these bits that are it has the ion channels that are trying to keep it in certain electric membrane, which is actually learned this yesterday. It's called Johnson Nyquist something. It's kind of the electric membrane. What it has is that something. And I think they've been kind of thinking it is kind of the limit. It is the what is just noise, whatever. But I'm thinking no, that's actually information. Of course, I'm an idiot, so I should not be listened to. But anyway, so then we have this action initial segment that has these gratings that are 190 nanometers apart, and what I can't say I am really saying this. I mean, all of this has been developing slowly. So I've been talking with Claude. I lose my mind, go bicycle, think about this and that. And so basically, that this would be a holographic projector in a way. It's sending out the state of the neuron body into forward. And anyway, one new thing about that in a little bit, but. And then there is another thing here that I don't even remember, but there's it's kind of like if you guys think like kind of like a projector, it's projecting the signal in a certain way at a certain frequencies, and there's a at the beginning of it there's a like when when the thing wants to spike, that's kind of like a complicated thing. When does a neuron want to spike and whatever. But so my idea, this was born out of that when we had this thing when we had a chessboard pattern. Like if this is stopped, this is just chessboard. It's literally just a chessboard. And I don't know what I was even thinking, but so I was sending a signal out from this homeostatic coupler that tries to stay in homeostasis, and it has a certain value, which is 1, and so this was being sent to the image to vector, returned this image into 256 numbers, so vector, and that we sent to a vector splitter, so we split that 256 into 16 numbers, and we're only sampling the beginning of it and sending to homeostatic coupler, and we got the ECG signal. And if you change these things, you would get different signal. But because I was having heart problems, this kind of like I was like, what the hell? How did we suddenly get this thing? This was not meant to be a neuron. This was just really literally me playing, and we got this thing. And I realized that first of all, like it doesn't have to be chessboard pattern. It can be any pattern. And actually, we are gonna get to that in a little bit. But so now, suddenly I was seeing that what if the neurons they have a pattern, and I was thinking of the ion channels and stuff that are done in the thing, And like I said yesterday, I only found out that there's this noise, electric membrane noise, and it's called Johnson/Nyquist. And I think they're thinking it's a limit, because Nyquist, I know it's a limit. Usually there's at the limit, there's always we get some sort of a pattern. But no, my idea is that there is a certain sort of a brush. This pattern is a brush. The signal that goes forward, it can together all of these billions of neurons, they are projecting something into something. And what is that something? Yet another idea. When I first started doing this was 2024 fall, and there's this guy called Joshua McFadden who was thinking about his theory for consciousness is that there is a field, electric field, that consciousness is in the field. And so basically he doesn't think it's in the neurons. But okay, so like today I really have been feeling like shit. And I was just doing these random things. Let's see, I'll show you some of this. So I was thinking of these like, because I was thinking about these chessboard patterns, like okay, what happens when you put them like this. And I had actually another version of this code that was actually, it was cooler. I wonder, did I save it here? But it would produce all sorts of weird codes. Okay, this was another thing, but so I was thinking about all of this. And how do you have many lattices when you are turning them? How do you get them to make an image? How do you do that? I know that images deep down do have the Moiré when they mathematically when they are treated with something called the fast Fourier transform, they produce these Moiré patterns, which was yet another thing I realized a long time ago. Let's see, I'll load that. So I have this. If anybody was watching me, guys probably remember better where all the files are than me now. But so, yeah, brain working at, I don't know, 0.1 hertz at this point. But so, okay, I had this thing where we had a image was turned into frequencies, and I asked you guys what happens here at the frequencies. You take just one frequency, ignore this. This was some weird ass idea, but what is this? This is a Moiré pattern, but it is not a chessboard. It's made out of sine waves. So, and some people think that brain does everything that it does. It's just spiking all of the sine waves. They add together and they do something, but do what? So my question was, how do we use these patterns to, I wanted the code where I give an image, and the image basically is made out of fields like that. So suddenly now we have kind of like what I was thinking, what if the neurons are like brushes? They have brushes, like this is one brush, and second brush, and third brush, and of course neurons, they have different shapes. People are wondering why do they have different shapes. What I'm saying is, what if there's kind of a reason why they are certain, they grow to be to certain directions. There is different sorts of neurons at different places. One thing that I've learned lately is that actually the eyes that I've been thinking is the projector. There's actually interneurons, I think they're called chandelier neurons and basket neurons that connect just to that ACE, action initial segment. And so, but anyway, so my point here was that what if that body is holding something like this, and together all of those bodies, they can project an image. And so I asked for a code, and here is the code. This is has those lattices, and sadly it starts at 100, so we don't really see when it goes really low, but it starts like at nothing like an image. So I wonder if I had a earlier poopier version of this. I guess I could quick ask for a version that allows us to see what happens at the very when we have only a few fields. But so that's kind of the spectral island idea, and a version that starts one field and goes up to 5000 whole file. Of course, you know, probably it's just a couple changes here and there. But so, okay, that spectral island idea, it's kind of like, that's what it is. This code actually is going to be, this code is going to be at let's see, it's at spectral islands, I think, version 2, I think it's here. Holographic image reconstruction. I have not even given it a thing here, but that's kind of like where this thing is going. And of course, there is probably holes mile wide, and perhaps this isn't how things are. But it's interesting that the ideas are kind of locking into place. But if this is how it was, then this, like when neurons are firing, they are sending like these little colors all together and they're painting the world. So basically, 1D signal is coming through the eyes, skin, everywhere to the brain, and the brain, through billions of years, you know, life has developed this ability where a signal is coming in, the brain creates this moment. And what's the reason for that? Well, it's survival. Because a tree can't really do much when something attacks it, but when we got animals and we got faster and faster, kind of like you're living faster and faster, what lives fastest sort of can fly away, do something, fight, attack, that's what life is all about. It's about survival, and somehow these neurons are just part of that evolutionary process. And but this is kind of like where the and of course this is called pribam's holographic theory of the brain. And another thing that kind of I think is kicking here is von Neumann, who is kind of like I guess key figure in computation. He was thinking that brain does not, and of course is right, that the brain does not think with zeros or ones. He was thinking it's wave computations, and this is wave computation. This is kind of like you have these signals coming in, and there is these fields, membranes, and they are being processed. There's a holographic projections and so forth. And anyway, but of course, I mean, like truthfully, it gets super duper complex. You bring in neurotransmitters and all the other stuff, but. And I could crack a book and read about how it actually really is, but I don't know. It's just not in my wheelhouse. But okay, so let's look still at the holographic reconstruction, so we can see a little bit crappier version of the well, let's just call it that. So which was the initial name? So we load an image. So this is still the same file as the other one. This just has less of these fields. So you guys can kind of see what happens at very low settings. So it doesn't start with an image. Like as you can see there, it's just a. So we are just adding those fields. We are just adding a field, another field, 11 fields, 32 fields, 52 fields, 72 fields. Isn't this it's kind of like I wasn't expecting that it's gonna work, but and of course what's behind here is the fast Fourier mathematics, which is well known. This thing looks like a holographic plate, like the classic holographic plate always looks like that way, but that's basically the idea, that the Johnson-Nyquist noise is a holographic plate scattered around, and the whole system is somehow able to project perhaps into the haptic field, the electric field in the brain, and qualia is somewhere there and whatever. But anyway, I hope you guys are well. Bye.